Alright, hello boys and girls, moms and dads. Welcome to Heroes Modern School Academy. This is 5th grade science, and this is going to be week number 14 of the curriculum. So today we are going to be talking about the periodic table, which is going to be a little bit deeper than what we talked about during 4th grade. So during 4th grade we had an introduction into the periodic table, but today we are going to be talking a little bit more about the periodic table, how to read the periodic table, what the atomic number is, what the atomic weight is, how can we calculate the number of neutrons of an element. We are going to be talking about all of those today. So if you remember from 4th grade, we talked about how the periodic table is going to be a list of all the elements that we know so far on Earth. So everything that you hold in your home, maybe it's a table or a chair, at a fundamental level may be broken down into any of these elements. So it's going to be maybe made of wood, which is going to trace its way back to carbon. Or maybe it's going to be made of iron, which is going to be tracing itself back to iron here, which you're going to see Fe a little bit later down the road. So how do we read the periodic table? So most periodic tables are going to carry this format that you're seeing on the screen right here. You are going to see that all the elements may be read from the simplest element on the left over here to the most complex element on the right toward the bottom right over here. So you read the periodic table from left to right, and then backward from left to right, and then downward from left to right, and then downward from left to right, and all of it like that. So if you see these little boxes over here, you're going to see certain numbers on top of those boxes. Well, the number to the top left is called the atomic number, and it represents the number of protons, which will be equivalent to the number of electrons as well, especially if the atom is in its stable form. Then you're going to see another number here, which is a little bit to the bottom of it over here. That number to the bottom is called the atomic weight. Now the atomic weight is going to be equivalent to the weight of, or the number of protons and the neutrons, which form the nucleus of the atom. So for example, hydrogen is going to have an atomic number of 1 and an atomic weight of 1.08 or something like that. And you can use that to calculate the number of neutrons that the element is going to have. So let's take a look at lithium over here. So lithium is going to have an atomic number of number 3, and then an atomic weight of 6.94. We can just round it up to maybe 6.9 or something like that. So that's how you read your periodic table. So let's try to commit some of these things to memory by answering some of these questions right now. So look at the periodic table above and identify the simplest element. Well, the simplest element is going to be the element that has an atomic number of 1, and that's going to be hydrogen. Just like you can see over here, hydrogen is 1, and that's the simplest element in the periodic table. Then you're going to be asking yourself, how many protons does he have? Well, he has protons. Well, 1 proton. All right, hydrogen has 1 proton. So question number 2, how many protons does lithium have? So you're going to look for lithium, which is Li. Lithium is going to have 3 protons, and that's going to be equivalent to its atomic number. All right, so they're asking us what is the atomic weight. So the atomic weight is going to be equivalent to 6.9. Just like that. That's the atomic weight. Now over here, they want us to know how many electrons does a stable version of carbon have. So take a look at carbon over here. So carbon is going to be C. It has an atomic number of 6. It has an atomic weight of 12.08. All right, that's the atomic weight of it. And then they want us to know how many neutrons does it have in its nucleus. So to calculate that, we're going to do this. All right, so we're going to do, let's clear the board. So carbon has uh, an atomic number, or let's just write it the way it is over there. Okay, let's clear this out. So carbon is going to have 6 on top of it, just like that. And then if we go back here, he has an atomic weight of 12.08 or something like that. All right, let's do 12 point, I believe it's going to be 12.08. Let's double check again. 12.011. Well, I think some people call it 12.01. Let's just try to do that. So the number of protons, which is going to be equivalent to the atomic number, is going to be 6, and of course which is going to be equivalent to the number of electrons as well in a stable form of carbon. So proton is going to be 6. There's going to be 6 protons, and there are going to be 6 electrons as well. We can represent proton by a positive charge and represent electrons by a negative charge. Now the atomic weight, which we are going to be representing by W, is going to be equivalent to this 12.01 that we're talking about. It's because 12 is going to be equivalent to protons plus neutrons, and which is going to be equivalent to 12.01. All right. Now, if we know the protons is going to be 6, so this equation is going to be 6 plus neutrons equivalent to 12.01. All right. So guess what? So the number of neutrons will be equivalent to 12.01 minus 6. Okay, which is going to be equivalent to, you guessed what, 6.01. That's going to be the weight of the neutrons in the nucleus of a stable carbon atom. All right, good work. All right, so let's take a look at another question over here. So we are going to be listing right now the first 20 elements of the periodic table: the number of protons, the number of electrons, and the number of neutrons. And all you need to do is to count and read the periodic table from the left to the right, and then back to another row, left to right. So let's go ahead and do that. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Sodium, magnesium, aluminum, silicon, phosphorus, and sulfur, and chlorine, and argon, and potassium, and calcium. So you're going to try to list all of that out in this part of your workbook so you can commit at least the first 20 elements of the periodic table to memory, just like that. Note there are right now about 118 elements in the periodic table. You may not necessarily memorize everything right now, but at advanced levels, during your advanced study of chemistry in middle school and in high school, we are going to have to commit all those things to memory, just like that. All right, so please go ahead and do those exercises and retain this information about the periodic table. Well, that's what I've got for you today, boys and girls. Thank you for joining me today. Remember, God cares about you, and so do we. And don't forget, there are different types of elements in the periodic table. I forgot to mention that. There are going to be metals, and there are going to be non-metals. Well, metals are the kind of elements that are going to be in the red boxes, in the yellow boxes, in the green boxes, and non-metals are going to be in the blue boxes. And you know what a metal is. A metal is a substance that can conduct electricity and can conduct heat, but a non-metal cannot conduct electricity and cannot conduct heat. An example of a metal is going to be lithium or sodium. Aluminum is going to be another example of a metal for you. An example of a non-metal is going to be something like carbon or boron, or something like let's see, another non-metal over here, phosphorus or sulfur. Okay, so those are going to be metals and non-metals in category. Just wanted to make sure we mentioned that before we wrap up today's lesson. Well, thank you for joining me today. God cares about you, and so do we. Bye-bye.
I'll be your hero's buddy, and as you study with heroes born,